joining this webinar today. It is on driving innovation in the Edge AI with Zadara. So I'm one of the TAS team here within Example IT, and I'm joined today with Steve Costigan, Zadara CTO, who's going to talk about AI and the Edge and the tricky terrain that that envisages and how to navigate it and get through it. So there will be a Q&A session at the end of this. If there's any questions, type in the Q&A tab, and then we'll pick those up at the end. So, Steve, over to you.
Thanks, Kevin. So just to introduce myself, Steve Costigan, CTO EMEA at Zadara. I'm heavily involved in a number of AI projects within Zadara, but also with our key partners, including NVIDIA. So I want to talk to you and take you through a little bit of a journey of really taking this whole thing from AI, what people are terming AI. A lot of people are terming it just around chatbots. It's much more than just a chatbot, and hopefully what I'm going to take you through is going to explain that journey and what you need to do on that journey to get to your destination. So with that, let me continue through. So at some point, you're on the start of your journey. If your AI journey begins today, you need to understand what that map looks like. And I presented up here a map of the London Underground. Interesting, I've just spent a couple of days in at London, and one of those things is you start your journey somewhere. From my case, that was into Euston. You want to get to somewhere else, which was NVIDIA. How do you get there? How do you plot your way across? And if you look at the London Underground, for example, across the last 100 years, it's changed dramatically, just like your IT estate will change dramatically and probably is continuing to do so. So it's not just where you are today, but where you want to get to, how you want to get there, and how long is it going to take you to get there. So first and foremost, I want you to start to think, how are you going to modernize your business? What are your business applications? Where is your data? Do you know where your data is? Have you classified it? Does your current application, does your data requirements, does that meet your company's needs today and moving forward? Does that scale in the way that you need to? Does that provide the business with the insights and the values that it needs to be able to not just survive, but progress in this new journey around AI? And really where I'm going to focus here is around where Edge works in terms of that. Everybody's familiar with ChatGPT, Claude, all of those very large scale GPT models. But when you take that to an Edge deployment, what does that mean? So can you utilize these technologies to improve the way that your business operates? If so, what's the timescales? What's the risks for you? Okay, and then from our perspective, where does multi-tenancy belong in this AI journey? So we see some challenges for AI at the edge. Data gravity is a major part of this. Gartner predicted something like 80% of the data that we generate actually never sees a data center. So if you're generating data at the edge and you want to utilize that or monetize that, how are you going to do that? Is that going to drive more into a local data center environment or a more regional data center environment? Or are you going to try and push that into a hyperscaler? What's the challenges around that? And then, there's the data validity. Can you actually transfer that data to a central model and operate within that environment in the timescales that your application needs? So some of the use cases I'm going to take you through are things like video analysis. Video analysis needs real time. So if you're adding 30, 40, 50, 100 milliseconds of latency into that, then you're not necessarily getting the real-time data that maybe you need. And then there's bandwidth constraints, data sovereignty issues, who's got access to that data? Can you keep your data local? And what does that mean in terms of regulatory compliance for you, etc. Then additionally, if you do centralize, what's the cost of getting that back? What's the cost of those egress charges? So these are all some of the challenges of trying to drive AI at the edge, because the more we drive AI, the more we drive data, the more we drive data, the more we drive networking. That means we're going to drive more in the way of costs, etc., in trying to drive that. So as we look to drive applications out towards the edge, that introduces new challenges. Those challenges could be more along the line of, how do I actually deploy a new application into an edge location and manage that centrally? If we look at modern application life cycles, then we're looking at maybe multiple teams, especially if you're running DevOps or you've got your own development teams. Team A may be working on a project, team B on a different project, team C, and at some point they may all need to come together, but you probably need to keep them separated and isolated in that initial play. So this is where we believe the importance of multi-tenancy and why AI adds to that load, because you've got to consider your data, you've got to consider the security and isolation of that. You may be bound by compliance and regulatory issues such as HIPAA, GDPR, etc. And you may also then need to further isolate that data based upon your own internal needs, HR, finance data, because as we start to introduce AI workloads into the workplace, then they may be given access to that data. If that then is not regulated and not transformed in a way that you're managing who's got access to that data, then you could be falling foul of some of those regulatory compliance issues. So on top of that, you've got to look at cost controls. Not all workloads are equal. Are you providing SSD storage infrastructure for something that's long tail, maybe belongs on object storage on HDD, for example? You may be looking at different applications and the noisy neighbor impact, because if you've not optimized your databases, then the moment that you start to put an AI inferencing system in front of that, you're going to add to that workload. That may add to the time it takes for that application to perform. So these are all some of the areas that you've got to consider in terms of your current estate before you consider how do you move to your desired state. AI agents are continuous. They're not like human beings. Human beings will work 9 to 5, etc. Typically, where we're moving to with AI agents is a continuous workload where they're continuing to operate on that data. That means things like backup windows change, how you protect your data, how you interact with that data all changes continually. So that changes your posture around business continuity, disaster recovery. And the ever increasing threat of ransomware is not going away. We've seen that certainly across the last couple of weeks in retail in the UK. That's not going to change. So you've got to build all of these layers into your posturing around AI and AI at the edge. What does that mean in terms of delivering AI inferencing? From our perspective, we believe this needs a multi-tenant infrastructure, whether that's microservices and running on Kubernetes, but it's certainly a containerized workload that is evolving as a need around AI. Those of you that are familiar with development and development systems will see that most developers now are operating in a containerized manner. You're running Docker, running Kubernetes. As we look across larger and larger organizations, and they're going to want to deploy these infrastructures, they're going to want to deploy them maybe as dedicated Kubernetes infrastructure, or maybe as a shared infrastructure and isolation within a shared infrastructure. So this is where the use of things like vCluster will enable you to operate with your own virtualized Kubernetes layer where you can deploy your applications and enable your DevOps teams and maybe even your users to operate in an isolated environment. The problem is that as you continue to add these different layers, you're adding to complexity, and trying to do this in a multi-tenant environment becomes harder and harder because the physical infrastructure underneath generally is not geared towards multi-tenancy. And whether you're an enterprise application or enterprise provider or a service provider, the ability to isolate and separate is a key part of security posturing. So from our perspective, we're providing a infrastructure layer that enables you to dynamically scale from a storage perspective, from a compute perspective, even from a GPU perspective. This underpins the critical layers around then deploying multi-tenant Kubernetes infrastructure on top. Because we're deploying a cloud infrastructure at the edge and deploying that within any location of choice, it means that you can build on top of that any particular model that you'd like to make use of. Typically deployments of Kubernetes are still being deployed on virtual machines. So the existence and the coexistence of virtual machines and Kubernetes and container workloads will continue as we see it. So with that in mind, having an environment that can deliver at the edge, virtual machine locations, virtual machine applications, and enable that use of containers is critical. And that's really something that we've built with this capability of bringing the cloud to you. Operating on a cloud VPC model delivers at the edge a true multi-tenancy, a true separation, whereby each of your applications can work in the way that you need. And that can offer many different things. You may have robotic desktop applications, so you may want to utilize something like Inuvica to provide a VDI environment and then automate that some way with an application that's running at that level. You may want to automate the database environment. You may want to automate different applications. So as you work through your own infrastructure and look at these different layers and segment them to work on a project by project basis, then you're going to look at those and say, is that suitable for an AI infrastructure at the edge? Not every workload is going to be suitable for an AI infrastructure. From our perspective, delivering edge cloud services enables us to offer you essentially whatever you need, wherever you want it. If you need high-speed NVMe drives to pass through into virtual machine instances for ephemeral data, if you're running log data, and I'll go through some of this in the use cases. If you're running environments that's got transient data and you need to process that at high speed at the edge, NVMe pass-through is perfect for that. We did a case study with CodeZero a couple of years back on doing that exactly as AI inferencing. Having EC2 deployments means that we can deploy using infrastructure as code, and again I'll touch on that in a short while. Means that you can scale different instances. You can scale up, you can scale down, you can scale wide. You can do all of this programmatically. And that's going to be the key for delivering AI at the edge. You need to be able to automate as much as possible. Relying on people to physically go and do things takes time. Automation is the key to any AI infrastructure. Choice of different CPUs, GPUs, again, enables you to mix and match based on your workload requirements. So it's not a one size fits all, gives you that flexibility to chop and change. The multi-tenancy capability enables you to offer that isolation. So you may have a database application that you want to run in one tenancy. You may want to enable access to that through something that we call direct peering. That enables the database team to manage the database services that are underpinning your AI, and your AI dev team just accessing those services in a completely separate and isolated environment. So with that, it then gives you the ability to dynamically scale up and scale out using auto scaling groups, and the use of premium instances of different CPU types enables you to match and change based on the change of your workloads. So I've touched on databases. They're critical in the AI world. I struggle to find any customer that doesn't operate in some way without a database. Very few are just running on Excel spreadsheets in the modern world. So the use of databases, the use of your data, do you understand where it is? Do you understand the value of it? This is critical on your AI journey. And if you're looking to deploy edge locations and you're looking to manage data that's coming in at the edge, understanding that and managing that becomes more and more critical. As we look more towards AI and AI inferencing, then this is where the frameworks are built on top of those databases, whether they're vector databases such as Chroma, whether they're traditional databases like Postgres, MySQL, etc. They're going to make use of those data sources. And then it's a case of which frameworks are you going to use? Are you going to use Crew AI? Are you going to use TensorFlow, PyTorch? Are you going to augment that with a large language model such as Llama? Are you going to chain this with LangChain and use agentic AI moving forward? And again, I'll touch into some of these use cases as we move forward. But what I hope you're going to appreciate is this whole environment is becoming more and more complex, but in that complexity, you get the simplicity from the automation. So you're swapping out one task delivered in one way with delivering it in a different way. So in that delivery model, that means that you're now looking at pipelines. You're looking at how you take a process and you automate that process. That may be utilizing Helm charts in a Kubernetes environment. It may be using NVIDIA NIM AI Enterprise and tightly integrating that into GPU instances that are delivering either single GPU or multi-GPU capabilities to enable you to operate those large language models or to operate those agents. And again, it will be a mix and match environment. Underpinning that is really, whichever way you want to go from an infrastructure provisioning perspective. If it's containerized, just running single Docker instances is not really going to be scalable for you because of the management overhead. So then you're going to look at, an orchestration layer that could be, a cloud native Kubernetes infrastructure. You may not want to manage that at all. You may want a managed service. That's really where the likes of our partner Tycoon Cloudworks comes in to be able to offer a managed Kubernetes infrastructure. You may want something halfway in between where you've got a management infrastructure, but you're still managing it. That's really where Portainer or Mogenius come into. Or you may want to build on a standard distribution, an EKSD, a Rancher, a K3S, or a MicroK8s. But whichever way you decide to go, whichever journey is right for you, from an infrastructure perspective, we're able to deliver, block file and object storage. We're able to deliver you compute, deliver you a cloud environment and a multi-tenant cloud environment, and certainly interoperate via our CSI driver into any of those Kubernetes offerings of choice. But to get to that point, you need to get to that automation. That automation is really about delivering infrastructure as code. And we've been on this journey for a number of years now, looking at deploying infrastructure, those that have worked closely with Amazon, with Azure, etc. You're familiar with, this infrastructure as code, DevOps automation capability. Zadara has also been delivering that, for a number of years now. So we're able to operate in a way where we're API first, whether that's a storage layer or a compute layer. We're able to deliver you an infrastructure that you can automate very simply, very easily. There's a link there to our Terraform registry, but again, the choice is yours. Use Ansible, use OpenAPI, use Terraform from HashiCorp or OpenTofu, whichever way you want to go. But to be able to take yourself on that journey around AI, automation is absolutely critical, whether that's from the physical infrastructure layer right the way through to your application layer. You've got to consider how you're going to do that automation. To deliver that automation, you've got to define your process. Therefore, you need to understand your data and you need to understand your data flows. So if we then look at the AI application delivery use cases, every organization is different. Therefore, every organization is going to have their own priorities, their own different ways. And here I've just highlighted some of the different use cases. You may be on a digital transformation journey. You may be taking existing legacy workloads. You're looking to move them from monolithic to more scale out infrastructure. You may be looking to build that agentic pipeline where you're replacing operations that may take a long time for people to do manually. You may be looking to take certain tasks, certain projects, and automate those and build a pipeline to do that. You may also be looking at how am I going to protect all of this? How do I keep my business operational, especially when I'm distributed across multiple locations? If you're manufacturing or retail or you're a global organization, how are you going to do that? What changes within your environment? Backup and archive. Your data is your lifeblood. So as you're generating more and more data, and generative AI is going to continue to add to this load. You're going to generate more data. You need to store that data. Then you've got to look at the value of that. Does that need to store on primary SSD storage, or do I need to be able to archive that down maybe to object storage, or maybe even off onto tape, or a Glacier type environment? Then looking at more modern application development and deployment, taking that DevOps culture of automation, being able to do things quicker than the old monolithic way of deploying applications. So again, it changes your processes, changes how you interact. Are you going to move more to a cloud native infrastructure, utilizing more of those Kubernetes infrastructure, using more of those application delivery models, using agents, using models such as PyTorch, scikit-learn to actually analyze your data. And then, you can't get away from it. Everybody's talking about VMware and VMware alternatives. We're one of those. We can deploy our infrastructure sat alongside a VMware environment, so you can coexist a Zadara infrastructure with your existing VMware infrastructure and migrate over time. Again, depends on how your workloads go. But then also, what does that mean from your infrastructure? Are you looking to deliver, as an enterprise, infrastructure as a service internally? If you're a large multinational or you're a large organization that wants separation, thinking like a service provider, has some benefits. If you are a service provider, being able to operate with true multi-tenancy and delivering, AI cloud infrastructure across multiple tenants then becomes, a key part as well. So, data. I love this quote from Mark Twain. Data is like garbage. You better know what you're going to do with it before you collect it. If we look at how much data we're generating, we're continuing to push more and more data. We're storing more and more data. I challenge many organizations to know whether they know exactly what data they have. Have they classified it? Are they removing it when they should be removing it? Are they doing everything that they need to do in that data management process? For a lot of organizations, that's a real challenge. As we continue through, we're already at the 200 zettabyte era. That's again going to increase when we look at this drive from IoT, sensors on cars, sensors on pretty much everything, video capabilities. That is going to continue to grow and grow and grow. So data management, what does that mean? What does that mean we need to do? We need, from an AI perspective, we need to understand that data. Where is the source of that? What is the value of that? What are we going to do with it? Do we need to keep it for the long term? Do we need to keep it for the short term? Is it just transient while we're generating new data? If you look at any large language model, you're feeding it data in terms of tokenization. It's giving you back data that is tokenized. Are you going to store that? If so, for how long? Do you then archive that? Where do you archive that? So these are some of the new challenges that we're yet to understand in terms of what we're doing with AI infrastructure. That data needs to be managed. It needs to be regulated in some way, whether that's internal or whether that's external. You've still got to regulate that data and access to that data, and especially when you're using those models to peruse your own internal data, something retrieval augmented generation. I'll touch on that in the next slide. But basically, do you understand where your data is? Do you have the skills? Every system is looking to deploy more data access, more analysis. We've seen the rise of the data scientists. Do you have those skills, or do you need to bring those in to be able to get to the destination that you're trying to get to within your own AI journey? So ingesting that data, cleaning that data is so critical. I've seen organizations that have just tried to take their existing data, throw that into an AI model, into a RAG model, and expect it to just work. Unless you understand that data, PDFs are a great example of that. If you generated PDFs and they're scanned images, you can throw those into any RAG model you want. Unless you've OCR'd that data, unless you've extracted the metadata, then it's just noise. It's just an image. So you've really got to start to understand what is it you're going to do with that data. You need to explore what the contents of that are, and then what is it you're going to extract from that, and how are you going to extract it and make use of it. So if we look at deploying a large language model and agentic applications, we've developed an example of how to use something onto a Zadara cloud environment. It's there on our GitHub repository. What we've done, we've taken Onyx, which is a very useful tool in terms of a RAG model. You can also deploy others like anything LLM. That will provide a front end to be able to query a large language model, a llama. Again, pick whichever LLM is suitable for you. Word of note, and again, something that I see in the field. People look at large language models and they look at the one that they want to deploy, and they immediately go to the biggest one. They'll want 70 billion parameters or 405 billion parameters, and they'll try and run that on a GPU that doesn't have the memory to support that model, and they wonder why it fails. And these are part of the reasons why, when you look at the edge and deploying inferencing at the edge in this way, you've got to be realistic. Does the GPU that you're looking to deploy, does it have the memory to support the model? If not, you're going to have to change your model, or you're going to have to change the quantization of that model. And then does the GPU support that? So again, it's part of that journey, understanding your data, understanding what you want from it, understanding the large language model and its sizing. And then, to augment that, you're going to take your existing data. That could be PDFs, could be Word documents, could be Postgres databases, etc. You're going to feed those in. Then you're going to support that with a vector database, with some embedding, some sentence transformers, and that will enable you then to make use of that data. Then you can serve that data up in terms of understanding it, gaining value. Maybe you're you're going to provide some automation. That could be using Argo CD and GitHub in a CI/CD environment on your data, so that you're able then to automate your own processes, the way that you deploy systems, the sizing of systems, etc. But then also, if you've got a support organization, feeding your support documentation or your help desk system, such as Zendesk, etc., feeding that into this model, and then being able to have your support operatives be able to query this data and gain the best answers for your customers. Then maybe also put a version of that out to your customers to be able to search a subsection of your documentation, maybe just your public documentation. So again, different ways of utilizing that, but it's key that you really start to understand where your data is and how that works. Once you've done that, then you can start to look at, okay, what are we going to do with that data? It's coming in. As we look at Internet of Things, that's typically streaming data, lots of textual data coming in from log files or types of log files. Are you going to push that into a Kubernetes infrastructure at the edge? Because it may just be gathering and doing local processing. That local processing, probably transient data, so a local NVMe to store, retrieve, and process that via GPU becomes an important part of the edge model. And then what are you then going to do with that data once you've processed it? Are you going to store that more locally, maybe on a NAS file system or block system, and then over time age that out maybe into object storage? And that's really where our tiering capabilities within our storage ecosystem enables you to do that all within a single platform. And again, I think that's what sets Zadara apart from most of the other players out there, is not only can we give you the compute, the GPU, the infrastructure in a cloud manner, but we can also provide that block file and object storage with true isolation between each tenant. So as we look at log management, it's critical from a security perspective, but it's also critical from an application availability perspective. Your applications will be generating logs. You're going to feed that maybe into a system like Splunk, but you may also be utilizing these sort of systems to be self-monitoring, whereby your GPU environments, your systems at the edge, they're generating logs. You may be feeding that back in and having some self-monitoring environment that is actually looking at, is this GPU stretched? Is this CPU stretched? Is this environment operating in an optimal way? Do we need to scale by adding more CPU nodes? Do we need to look at the I/O path into our storage? Is our storage, struggling because we don't have enough SSDs, or we don't have a large enough number of CPU cores into that storage environment? So therefore, we need to scale that. So again, all encompassing, having an environment that you can feed those logs into and analyze those logs. Again, at an edge, you want to do more and more automation. So when you're looking at that automation, it could be, as I mentioned earlier, support ticket pipeline. Customer comes along, they're seeing some issues in their edge location. Can they feed that into the help desk system? The help desk system is looking at previous tickets. It's looking at how those problems were solved. The support operative can feed that back to the customer, or actually make some changes within the environment. Customers may want to do other things. They may want to look at their billing information. For example, there may be a separate environment in there that's a private API mechanism into their AI workload, or it may be just a more public generic, I've got this problem, what can I do about it? So these are some of the use cases that we have. But I think more importantly, as we drive more and more of this into the edge, and we look more and more of enterprises adopting AI workloads, having a supported mechanism, not just an open source mechanism, becomes more and more critical. And this is really where NVIDIA with AI Enterprise and their NIM blueprints becomes a really good starting point for you to consider where your journey begins and where you want to get to. So yes, it's a paid for model from NVIDIA, but you get all of the enterprise support from NVIDIA for their models, and you can build that on top of the Zadara ecosystem and infrastructure. So what does that mean? It means that if you take a agentic model, maybe an NVIDIA NIM model, along with a large language model, and you're deploying agents, you may have one part in a VPC that is completely open source. You may have a combination of things that are running from NVIDIA NIM and augmenting that with your own code. But one thing that is really gaining traction right now is the use of agent-to-agent interaction and agent-to-existing system interaction. So if you look into what's going on, the use of MCP servers, so MCP servers are going to be agents that are looking at the context. So it's model context protocol. So they're looking at as an interface from your large language model into your database or other system, being able to query that data and feed that back into the LLM to give you a generative AI response. Then, as we look at what Google released back in April with the agent-to-agent protocol, is further augmenting that MCP level, whereby you're going to have agents talking to agents, and therefore they're going to start to make decisions on your behalf based on the data that they're seeing and the results of what's going on. So this is a really exciting area of automation, especially when you want to look at things like, what's going on with my data, who's got access to it, am I under the threat of a ransomware attack. Being able to implement these things is really critical, I feel, in the future. So you've got to start to think about operating as a manager. What is it I need to be able to operate this model? What is it I need to be able to operate it at the edge? What do I need? Which personas do I need? Which agents do I need to actually take me on this journey, and how much can I automate? So I mentioned NVIDIA NIM. They've got some great blueprints, different ways of working with large language models, doing things like just reporting mechanism, automating the reports and diagramming of your systems, automating the creation of new documents and serving those out to customers. But I feel this is also a really big one in the market in terms of edge video analysis. Everywhere we go in this country, video cameras are there. What is it we're typically doing? They're very passive. We're relying upon humans to make decisions based on that video content. If we can automate that, and at the edge, you have to try and automate it. If you've got too many video cameras, there's no way you can have enough people looking at what's going on. So from security workloads and being able to do things from an automated perspective with video technology, I think this is a really useful use case. And I'm not just talking about people video, I'm talking about manufacturing systems, retail systems, pretty much any system that you can gain video content and classify it, and you can put it through a pipeline. And I think this is a really exciting area where we can take AI at the edge. Of course, you've got to be able to back up all of this, and to be able to back it up, typically you're going to need something that's aware of the context of the application. If everything is stored in a VM, then you can just back up the VM. But if everything is in a Kubernetes layer, then you need to understand the pod structure, you need to understand the context of the model, therefore you need a backup system that understands that. We've worked very closely with Kasten, now part of Veeam, for a number of years in terms of this model, whereby you can deploy your Kubernetes infrastructure of choice. You can use Cast and K10 to back up to our object storage, and that gives you a migration path and it gives you a distribution path. Especially when you're looking at edge technologies, being able to back up from one location and restore in a completely new location. That gives you business continuity, disaster recovery, and also distribution and migration options. Okay, that's me done. From this perspective, I'm open to questions.
Yeah, thanks for that, Steve. So now the questions and the Q&A session is now open. If anybody has any questions, if they can type them into the Q&A tab, then we can pick them up and start having a look.
We've got a shy bunch, Kevin.
I was going to say, they're very shy out there today, aren't they? Either that or they're all very confused and trying to work out what it is that they now need to do.
The key thing is you've got to understand what you've got, and you've got to understand where you want to get to. That understanding your data is so critical in any AI journey. The biggest failures, and I think the stats out there are pretty horrific. Something like 65% of POCs fail, and I think that's because people there's a disconnect between IT and management. Our management go, we must AI this, and IT go, how are we going to do this? And there's no real structure in terms of deploying that. And I think it needs the business, i.e. the management within the business and the IT infrastructure and the automation teams to come together.
Agreed. Thank you. Actually, it was interesting that the bit at the end there about the NVIDIA as well. So I hadn't realised that. So that's going to be, I think, something that's going to be quite useful.
Yeah, I mean, NEAM's really interesting because if you look back at the history of NVIDIA AI Enterprise, they were trying to license things based on a per GPU basis, and it was very difficult to understand what was coming. And really what they've done with NEAM is they've packaged these blueprints, and they continually build out blueprints, and they work with partners like us to build these blueprints out. And then it gives the idea of what's the art of possible. What would I need to do to deploy that video analysis piece? Well, actually, if you go and create a developer account, you can run this on a test environment, and you can deploy those images and those instances very, very quickly. That then gives you the basis for you then to say, okay, how do we go and do this in a production environment? So I think as a starting block, it's a very, very good way to get started.
Yes, thank you for that. We have a question that's just popped up. What is the current skills gap, and how do we address that?
I think the skills gap is huge, and it's getting bigger. It was funny, conversations yesterday with NVIDIA. The most organizations just don't understand where they need to be and where they're at. Trying to find people with the right skills is becoming harder and harder. So I think you're now starting to look for people that have got different skill sets. I think we're moving away from just having people with knowledge to now we need people who are more problem solvers, people who can ask the right questions. And that's why I put that slide up of think like a manager, because you're not necessarily trying to think, how am I going to do this? You're having to think, what systems and what agents and what other parts, moving parts, am I going to need to be able to address this? If you've not got Python, if you've not got Linux, if you've not got Kubernetes skills in-house, then you need to go and find them, because that's probably the way that you're going to be able to move into this area. If you're looking at other systems, Microsoft are doing lots of things around Copilot, etc. But that introduces its own challenges because there's data sovereignty issues in terms of who's got access to your data and what you're doing with it. So I think the skills gap is huge. I don't see that closing very quickly unless we start to educate people from a very young basis in this country. And I mean, teaching kids AI and moving that through the structure is pretty critical.
It is, and thank you for that. So Alex has asked if this is recorded. Yes, it is going to be recorded. It has been recorded, and then we will be sending the recording out to everybody that were registered after the event. I think that is all of the questions, unless I've missed any.
I'm aware that there's a lot of content in there, Kevin. There's a lot to digest from people, and I think the key message from my perspective is understand your data. Yeah, understand where you are, and then go and find the right people in your organization to get you to where you need to get to. And if you don't have those skills, go and find organizations like Zadara, like Example, that can help you on that journey.